Hi, in this video we're going to be looking at the extended Euclidean algorithm. I'm going to try and make it as easy and simple as possible. I know it's something that everyone gets caught up on. It's something that took me ages to work out as well. So I'm hoping that I can simplify it in a way that helps you out to be able to pass your exams and your lectures, whatever you need this for. Normally, we look at the extended Euclidean algorithm for when we are trying to calculate the value of d in RSA. So that is the basis of this video. Hope you enjoy. So first up, we're going to look at the example from a previous video. Just a reminder on the right there, p and q are random primes. N equals p times q. R is p minus 1 times q minus 1, and then we've got a value for e. On the left-hand side, we've got 11 and 3 as our P and Q values, which makes N 33. It makes R 20, and we've chosen the value of 3 for E. And as a reminder as well, D equals 7. Spoiler alert, it's an example from a previous video. I keep that in there just so you can see what we're going to get out of it. You can kind of cross-check it with what value you're expecting, and I'm not just throwing a random number at you. So yeah, let's jump into the extended Euclidean algorithm. On the right hand side, we've got another reminder. Phi n is 20, or r. E equals 3. And what we want to do is find the value of d such that e times d mod phi n equals 1. In our case, this is 3 times d mod 20 should equal 1. And then we've broken it up into the Euclidean algorithm and the extended Euclidean algorithm, also referred to as back substitution, which we'll get into in a moment. But firstly, from the Euclidean algorithm, let's get started. So what we need is we need our phi n value and we need our e value for 20 and 3. We've got that here. A lot of people write this out as like 20x times 3y equals 1. It complicates things. It's not needed, so we're just going to stick to what we need to be able to get the right answer out of this. So what I want to do is I want to take my value for phi n, which is 20, put it on the left-hand side, and we've got 20 equals, and then we want to take our value for e. And we want to think about how many times does our value for e go into our value for phi n. So how many times does 3 go into 20? And here, what we've got is 6 times. We've got 6 times 3 is 18. And then so we've got a remainder 2. So how we write this is 20 equals 6 times 3. How many times 3 goes into 20? Plus 2, our remainder. So there we go. That's how we got our 20 and 3 values. And that's the question we're asking. How many times does 3 go into 20? And this is just how it's represented. You don't really need to worry about why. You just need to understand that this is how it's represented. That's what this means. Okay. And then what we want to do is take it a step further. So we take our value in brackets from before, which was 3. It's also our e value. And then we want to take the remainder of that first equation, which in this case is 2, and then chuck that in the brackets. So now we're getting this equation where we have 3, our e value, equals how many times does 2 go into 3? Once, so 1, then 2 in brackets, plus 1, which is our remainder. Okay, and I'll say that again just to make sure that it's really drilled in. We've taken our e value, and it equals the number of times 2 goes into that value, which is our remainder, plus the remainder, which is 1. This is a small number example. Sometimes you'll have a couple more steps where you'll literally just repeat this, take these values again, take it down, until you get plus 1. Once you get to that point, you're done, you're finished, that's it. Okay? And now this is something that I've never seen any other video write down, but it's so important. So we're going to translate this now. So what does this actually really mean? We want to rewrite these values. So this first one here, we've written 2 equals 20 minus 6 times 3. How did I get that? 2 is the remainder. 20 is our subject value. And minus 6 to 3 in brackets is this value here. All I've done is I've rewritten this equation here to make it equal our remainder. Again, you can just understand this by getting how to rearrange this equation. So I'll say it again. You take the 20, you take the number in brackets here, the 6 to the minus 6 times 3, take one away from the other, and that equals your remainder. And we can think about this logically as well. So what's 6 times 3? It's 18. 20 minus 18 equals 2. Cool. Sorted. And then we do it again. So now we do it again for the next line. So now we take our remainder, 1, equals 3, this first value, minus 1 times 2, this value with the brackets. Okay? And we don't actually need these right now, but we're going to be using them in a moment. So it's really important that we understand these two equations here. So now we move on to the extended portion. This is the really tricky bit that everyone gets stuck on. So hopefully we can clear it up a little bit. But here we go. So step 1, we take our value for 1. What is that? That's this one here. 1 equals 3 minus 1 times 2. That's what we mean by that. It's also just this last equation here rearranged. So we write that down. And now we want to rewrite it because our 3 is all alone. We don't want it to be alone. We want to give it a friend. So we put the 1 in front of the 3. It just puts us in, we're just rewriting the exact same equation, but so it's consistent. So now we've got 1 times 3, also known as 3, minus 1 times 2. Now step 3, we want to substitute our value for 2. What do I mean by that? I want to take this value, so 2 equals 20 minus 6 times 3. That's the value that I want to substitute, because what I'm doing here is I'm just plugging this equation where the 2 used to be. So where we got 1 times 2, I'm replacing that with 1 times 20 minus 6 times 3 in brackets. Still equals 2, but we're just rewriting it because that's going to help us get to our answer later on. And now we want to simplify it. So I've written this out here to try and make it clear. I get that it's probably not very clear, so I'm going to talk through it quickly anyway. So this is a bit that took me ages to get, because how do you get from step 3, this equation here, to step 4? And this is just me not being very good at maths, to be honest with you. So that's the audience I'm trying to cater to. So if you're like me and you struggle with this bit, I'm just going to explain it really quickly here. So what we want to do is simplify this equation. That's all we're doing. So we take our 1 times 3 and we want to take it away from anything else that's times 3. Okay, so in this case, we want to ignore this minus 1 times 20 value. All we want to look at is the 1 times 3 and the minus 6 times 3. So we do 1 times 3 minus 6 times 3, also known as plus, and we end up with 7 times 3. And then what we left with, this little 1 times 20. Okay? And that's the result. 1 equals 1 times 20 from the middle bit here, minus the 7 times 3 from taking 1 away from minus 6 times 3. Okay? Now move on to step 5. So now I want to substitute our value for 20. So exactly what we did here for 2, we now want to do for the 20. And how do we do that? We look up here in the top left. 20 equals. Perfect. We already know what 20 equals. So we take this value, 6 times 3 plus 2, and substitute it for that 1 times 20 we got down here. So what we're left with is 1 times 6 times 3 plus 2 minus 7 times 3. And I clicked a little bit early, but yeah, we want to simplify again. So we're left with 1 times 2 minus 13 times 3. Now how do we get to that? We did 6 times 3, because I know that we've got another thing times 3 over here, so we want to pair them together. 6 times 3 minus 7 times 3. And that equals 13 times 3. And then what are we left with? 1 times 2. So we write it out as 1 equals 1 times 2 minus 13 times 3. And now we've got everything that we need to get our d value. So step 6 is to take our value for 3. So what are we multiplying this bracket by? And take this away from our phi n, which is 20. And here's the result. 20, phi of n, minus this 13 number here equals 7. We know our d value equals 7, so we found it. We've completed the extended Euclidean algorithm. And yeah, I'm not going to say that's all there is to it. It's awkward. It's a little bit complicated. It's really hard to get your head around. But once you're there, it's pretty straightforward. You can repeat it for other numbers. But what I'm going to do is I encourage you to spend a bit of time on this. If you don't get it first time, rewatch it. Maybe rewatch it again. You just need to understand where these values are coming from. And once you can do that, then you're going to have no problems using this algorithm to find your d values. Yeah, and I'll leave it there. I hope this has been helpful. I hope this is a clear explanation. If it is and you're happy with it, let me know. I'll be glad to hear it. But at the same time, if it's not a good explanation and you're still confused and you're still struggling with this, then please let me know as well. I'll be more than happy to reply in the comments to try and help out. But yeah, that's all I got for you. So thanks very much for watching. I really hope this has helped, and good luck using this in the future.